students, coming to our next topic, that is primary indexing. So this is one of the indexing technique that is mostly used in the database management system. So let us see what is this primary indexing. Primary indexing, I already said, it is nothing but it is a primary key. The primary indexing is combination of primary key and it should be the ordered data. So whatever the data that we are accessing, that should be in ordered. So that is the main thing here you have to note it. In the primary indexing, you have to know the primary key of your database and your table, and it should be whatever the data that is means the database is accessing, that should be in ordered. Okay, so it is a ordered file whose records are of fixed length. So, and one more point is it is ordered file and whose records are of fixed length size. So all the records that are present in the table, okay, in the file, that should be a fixed length size and with two fields. It is having two fields. So first field you make it as a primary key, okay, and the second field is the pointer to data file. Okay, so I already said the index structure. So the index structure consisting of the search key, okay, that you call it here, you taking as a primary key, and the pointer to the data field. So this is the structure of the indexing. So if you take it a primary indexing, the search key should be a primary key and the pointer to the data field, so to which block we are searching, so that related address will be stored in this pointer, okay, pointer field. This is about this primary index. So primary index consisting of primary key and the data that should be accessing in the tables, that should be in ordered data. So here index entry is created. First record of each block, you call it as a block anchor. So for whatever the index entry is created for first record of each block, called as block anchor. Okay, that you have to be noted here. So here the index entry is created. So this is an index entry. So whatever the index entry is created for first record of each block. So here the records are there. Suppose this is the block data file. So in the data file, you are having blocks. So in each block you are having records. So here the index entry is created. Okay, index entry is created for the first record, only to the first record of each block. Okay, so the index entry is created only to the first record of each block. So this block entry will be stored here and this block entry is stored here. Okay, this will access. So we are not creating for all the records, okay, only to the starting record of each block index entry is created. This you call it as a block anchor. Or you get it? So the block anchor is nothing but an index entry is created first record of each block. This you call it as a block anchor. So I will clearly explain by taking the example, so that you call it as a block anchor. And another point is, in the primary indexing, number of index entries is equal to number of blocks. Okay, first here I am explaining all the points. So what we are using in the primary indexing. Later we will take the example and we will discuss about these points in that example. So here the first point is, I said it should be a fixed length size and with two fields. One will be the search key, that is the primary key, and the pointer to data field. And the next is index entry is created for first record of each block. First record of each block, that you call is a block anchor. And next is number of index entries. So whatever the index entries here, that should be equal to number of blocks. So here I created 2 blocks and the index entries are created 2. Okay, so this point should be noted. Number of index entries should be equal to number of blocks. Next point. So here the number of access required. So number of access to the blocks required is equal to log n to the base 2 plus 1. So this is the formula to calculate how many access are required, how many blocks we can access to find the required field. Okay, required value. So number of access required, the index is accessing to number of blocks. The formula is log n to the 2 plus 1. Log n to the base 2 plus 1. Here n you call it as number of blocks. Number of blocks acquired by index file. So here I am acquiring two index files. So number of blocks acquired by index file, that you call is n is represented as number of blocks acquired by index file. So why here we are putting 1 plus 1? So here the plus 1 is to reach to that particular record in log n to the base 2 block. Suppose here we are our value, whatever we are searching for the search key, that is present in this block. Okay, so only the starting record anchor block anchor will be there. Okay, so up to here it search log n to the base 2. Okay, so now we have our value will be present in this third place. In the second record, the third place, here the value is present. So for searching for the next 2 records, we are 2 or more, means 1 step extra added. So that's why we are adding one more search plus 1. Okay, after reaching the block starting point, that is the log n to the base 2 is reaching to the starting point of a block, means starting record of a block. So to search for the required value in that block, you have to add plus 1. So that will be the formula for to access blocks required. Okay, so let us see one example. So here you can see the example. Actually, this primary index will be, it's a dense index or a sparse index. Okay, suppose if you take the dense index. So I already said dense index means index entry. Index entry is created for every search key value. So here the index entry is created for every search key value. So here we have taken the search key value as account start. So this is the search key value. So you call it as a block anchor. Okay, block anchor. So this is a search key value. So in the dense index, we are creating search key for every search key value. Index entry is created for every search key value. Okay, so these are all the search key values. So we are creating index entries for every search key value. So here you can see this is one entry and this is one entry and this is one entry. Means like that we are creating index entry for every search key value in the data file. Okay, so this is your main data file and this is the index file. So in the dense index means we are creating an index entry for every search key value. We are not taking the starting one. We are creating an index value, index entry to every key. This you call it as a primary dense index. Now coming to the sparse primary sparse index. So what is a sparse index? Means index entry is created for only to some records. Okay, only to the some records means here the index is created not for all the records, only the first record of every block the entry is made. So here you can observe the search key value here is account. Okay, so this will be the search key value. I said this is the block anchor you call. So here the index entry is created only to this starting record of each block. Okay, so instead of searching all the key value entries in the index file, okay, this is the index file. So this is the key value key, and this is the pointer to that block. Okay, so A10 is a search key. So only to the starting of the record, starting of the block, starting record of the block will be entered in the index entry. Only starting record of the block is entered in the index entry. Okay, here also. So this you call it as a log n to the base 2. Means up to you can calculate search log n to the base 2. Okay, if you want to reach to the particular file, particular record in the block, you just add +1. Means one more search to go for that particular record. Okay, so this is a primary sparse index. So instead of creating an index entry for every search key value in the primary sparse index, we are creating only the first record of every entry. Okay, so the index is created only for created for all the records. Only the first record of every block the entry is made. So for this block, the first record entry is made in the index file. So the first record of the block entry is made in the index file. The first record of this block entry is made in the index file, rather than entering all the search key values in the index file. So this is about the primary sparse index. So let us see the example. Okay, here the calculation. So see here. Let us take here we have to find the average number of blocks access with or without index. We want to search how many blocks. Okay, so here we have to find average number of block access with or without index. How we are calculating, let us see. Here the number of records are 30,000. Okay, so here the records they are saying that, so all records is up to 30,000 are there. Okay, and the block size is 1024. Okay, here the blocks, this is the hard disk. Okay, this is a hard disk, and here the blocks are there in the hard disk. So here the block size is 1024. They are saying only the size. Okay, size is 1024 byte, and the strategy they are following is the unspanned. So what do you mean by unspanned? I said unspanned means a single record always placed in one block. In the last videos I said the spanned and unspanned. Spanned means suppose if your record is half of the record is stored occupied this block, and another half of the record is occupying another block, that you call it as a spanned. Unspanned means only one complete record has to occupy one complete block, rather than dividing the record in one and another two. Rather than using the two blocks, one record should be occupy only one block, that you call it as unspanned. So here also in this problem also they are following the unspanned strategy. And the record size is 100 bytes. So for each record size they are saying 100 bytes. Here the block size is 1024 and the record size is 100 bytes. Now they are saying the key size. So key, why we are using the key? For searching the particular record. So index key size is 6 bytes. Okay, and the pointer size is 9 bytes. So the structure of index key consisting of key plus pointer. Okay, so here 6 plus 9 means the 15 byte size here. So index key size is 6 bytes, pointer size is 9 bytes. Now we have to find the average number of block access. So let us see. First, data records that can fit in one block. So in this one block, how many records we can fit? That we have to be calculated. Let us see what is the block size. 1024. 1024 is the block size. Okay, how many records? What is the record size? Record size is 100. Okay, so 1024 by 100. So you will get the data record that can fit in one block. Total you get 10.24. But we have to take only the whole numbers because this is unspanned. Okay, so unspanned means only the records that are fit in one block you have to be taken. So that is 10 records. So one block you can place 10 records. So in each block you can place total 10 records. So in each block you can place 10 records. This is clear. Now coming to total records, they are saying 30,000. So total records are 30,000. So now total number of blocks. So how many blocks can be placed in the data file? Means in the hard disk. 30,000 by 10 records. You will get 3,000 blocks. Okay. 30,000 records are there. To store the 30,000 records, we require 3,000 blocks. So in each block, 10 records will be stored. Are you getting? Okay. Total 30,000 records are there. 30,000 records are there. So in each block, 10 records we can place. So how many blocks we have required? So total 3,000 blocks. 3,000 blocks. In each block 10 records. Total number of records are 30,000. Okay. Now coming to. So without index we can need 12 blocks to access finding the record. With index. Okay. Let us see size of index is 15. So I said key size 6 and pointer size 9. So total it should be 15. So size of index we get. So if you want to get the index record size or block size, 1024 is the block size. By index size, you get 68. Because this is strategy is unspanned. Okay. So now the index records is equal to. We are finding the index for the searching of records and searching of the blocks. Index record is equal to number of data blocks is equal to 3000. So we are having 3000 blocks. Okay. So number of index blocks, we are finding the index blocks. So 3000 by 68, we will get 45. So now to access the average number of blocks accessing, how many blocks we are accessing? Okay. So that is the log 45. So this is a formula, log n to the base 2. So n is the number of blocks searching. Okay, 45 plus 1 is the to reach to that particular record. To reach to the particular record, we are searching plus 1. So log 45 means 6 plus 1, you will get the 7. Okay, average number of block access is 7. This is how we are calculating the primary indexing. Thank you.